In this lesson, I'm going to give you an introduction to algebra. Algebra is simply an extension to all the rules you learn in arithmetic, but now we represent numbers as alphabetical symbols or letters. Let me show you why. If you live in the UK, oven temperatures are normally shown in degrees Celsius. This also applies to temperatures in weather reports and so on. So if you need to set your oven to 180 degrees Celsius, you can find the equivalent temperature in Fahrenheit using this algebraic equation, where the letter F is the answer in degrees Fahrenheit, and the letter C represents the temperature to convert in degrees Celsius. This equation gives us a way to convert any temperature in degrees Celsius into degrees Fahrenheit simply by inserting our Celsius value in place of the letter C. So our value in Fahrenheit becomes 356 degrees Fahrenheit. And it's also worth noticing here that when we place two letters side by side, or a number with a letter side by side, it's simply a shorter, more concise way of saying that those numbers multiply together. One of the great things about algebraic expressions like this is you can also do the reverse. You can convert a temperature in Fahrenheit into degrees Celsius by rearranging the equation, and this is something that I'll explain in more depth in a later lesson, but I'll just show you quickly here how this is done. Let's look at another algebraic example. Imagine you're an electrical engineer designing a circuit. You need to reduce the electric current flow between 2 points in a circuit so that you don't risk damaging sensitive components. You decide that a 1 megaohm resistor will be sufficient, but you only have 200 kiloohm resistors available. Luckily, you know that if you place resistors in a series, one after the other, their resistances add together. We can actually write this as an algebraic equation. So here R total is equal to R1 plus R2, and so on. In other words, our equation tells us, in a very concise way, that the total resistance is equal to the sum of all the resistance in a series. This looks rather intimidating if you haven't seen this before, but equations are just very compact ways of describing an idea or a set of steps you have to perform without having to write really long-winded sentences. This does make maths very hard to learn, because we have to translate our thoughts and ideas into this mathematical language, but the advantage is we can communicate exactly what we mean without having to deal with the subtleties of everyday spoken language. There's one more thing I'm going to mention in this video. The symbols and letters in an equation can either be constants or variables. Now, constants are numbers in an equation that are fixed. In other words, they never change their value. An example is the 32 and the 9/5 values in our Celsius converter equation. The C and the F symbol, on the other hand, are called variables. These symbols can represent any one of a collection of real numbers. Another interesting equation that contains both variables and constants is Newton's law of gravity. Now I'll be covering Newton's law of gravity in future videos, and we'll really go into depth about what this equation means. But in this equation, the letter F represents force. And what this equation tells us very concisely is how much gravitational force to expect between two objects that have masses of m1 and m2 when separated by a distance of d. But the symbols F, m1, m2 and d are variables in this equation. But the letter G is a constant called the universal gravitational constant. The reason why it's written as a letter rather than simply a value itself is because it's a rather long value, and it's neater and easier just to write G instead. In the coming lessons, I'm going to walk through more algebra rules, so you can feel more comfortable answering questions about them in maths and physics. I really appreciate you watching these videos, and I'll see you soon.